Hello everyone. You all have seen in my earlier videos about the working, the construction, working of the truth tables of the logic gates. Now in this video today I would like to tell you about the applications of logic gates in our real life situations. So we are using it for constructing a burglar alarm and a fire extinguisher. Simple basic logic gates is what we are using. Let us see, this is a virtual lab that I am using where you can do the experimentation, try out, practice as many times as possible. Okay, so basically as you can see from here, this particular circuit is constructed using one AND gate and an OR gate. Okay, so AND gate is used to extinguish the fire, OR gate is used to raise an alarm. Okay, so alarm is raised either there is a smoke or some other thing, something like a fire. If both of them are noticed or one of them is noticed, an alarm is raised. If smoke as well as a fire both are seen, it must be put out. So you are using an AND gate here. So that is basically AND is on when both the inputs are high only. OR is on when one of the inputs is high. So this basic principle is what we are using here. So keeping this in mind, what you have to do is you have to fill up this truth table. It's already given here. You have instructions here, components here. Components will not be highlighted if the truth table is not filled. Okay, so since I've already filled, let me just check. I think, okay, reset and reset. Suppose you fill up this data in a random way without even thinking whether it is correct or not. Let me just put it as a random one. Without knowing, suppose you do this, it will tell you that it is some problem is there, you fill it up properly. So now what you have to do is fill it up properly. Now you check. It says, it prompts saying that the data you entered is right data. Now you can place the components. See, this will not be highlighted unless the truth table what you've given is correct. So components, this is the list of the components that are used here. Breadboard, if you click on this, breadboard will come. Click on this 5 volts DC supply. For all these digital circuits, you require a power supply not exceeding 5 volts. So this is a supply plus and minus. Digital switches A and B. A is for the smoke sensor, B is for the heat sensor. IC 7432, it's an OR gate. IC 7408 is an AND gate, and this is an LED. Now what are the connections that you have to make? Both these gates require a power supply of 5 volts. Okay, and pin number 14 is connected to the power supply, and negative is connected to, or ground is connected to pin number 7. So now this is your 14th pin. You can see here 1 to 7 here on the lower side, 8 to 14 on the higher side. So this is your pin number 7. Pin number 7 is going to the ground. Similarly from here also, pin number 7 must be connected to the ground. Maybe another power supply. Since it's not allowing one more connection, what I've done is I've taken the 7th pin to this point, and the same pin is going to the ground here too. So let me put this 7th pin also connected like this to the ground. Similarly, 14th pin of this is connected to the power supply. Since this 14th pin also needs to be connected, I will connect it to this 14th. This way also you can do. Right. Now LED is connected to the, this is your, which gate is this? 7432, it's an OR gate. So you require the switches to be connected. This is to A, that is a smoke sensor. This is a heat sensor. These are the inputs. Similarly, you must connect the inputs even to this gate. So since it is not allowing you to connect more, you will connect it like this. 1 to 1. So both inputs are A, both inputs are B. Okay. Now connect this positive is anode, this is cathode. So cathode always goes to the ground. Similarly, this cathode also goes to the ground. As you all know, the breadboard connection is such that the blue ones onto the top and onto the right are horizontally connected, row wise. That means this row is different from, the top row is different from the bottom row. Same is the case here too. Whereas the middle of the board is vertically connected. That means 1, 2, 3, 4, 5. Each of these 5 holes are connected internally. These are all internally connected. But this part of the breadboard is not connected to this part. As you can see, all these red lines are all connected. Okay? All these horizontal blue lines are connected. So then we've done ground connection. So one LED, let me connect it to the output of the first gate, that is pin number 3. The other LED is connected to the output of the second gate, that is pin number 3. Right. So now check connections. It says connections are correct. Then only the simulation button will be on. Start simulation. So 0, 0. Suppose you give both of them 0, 0. Both extinguisher, that means there is no alarm. No requirement of an extinguisher. Suppose I switch on. So what is it happening? Smoke is coming. So first it raises an alarm. Only smoke, so first an alarm is raised. It is on. Also heat sensor is on. That means something hot is happening. Then also alarm will be on. What happens? That means there is a smoke as well as heat. So alarm has to be on and fire extinguisher also has to be on. So this is how you do this simple application of the basic logic gates of OR and AND gate. The same thing can be performed in your lab. Take a small breadboard, 2 ICs, a power supply of 5 volts, 2 LEDs. In the lab, maybe to safeguard the LEDs, you need to connect a small resistor of 100 ohms in series so as to protect it. Okay? So this is how you do this. In the next videos, I will show you other applications of these gates. Okay?